Welcome back. Go ahead and open your books, page 395. We're going to use the book a little bit today and some notes as well. So yesterday we mainly focused on algebra tiles. Today we're going to learn the box method. We've already learned it for multiplying, but now we're going to do it for factoring. So if I'm looking at example A in lesson 27.1, we're going to factor x squared plus 12x plus 32. Okay, so that's like ax squared plus bx plus c. So when we create this, we're going to have a 2 by 2, so you're going to have 4 squares in your box. The x squared always goes in the upper left corner or box. And my c term, my constant, which is 32, that goes in the lower right box. Then we need to figure out what is going to go on our blank diagonals here. So we need to look for numbers that multiply to get 32, which is my constant term, my c value, and that have a sum or add to get that middle x term. It's called b, and that would be 12 in this case. Okay, so step 2 shows you different factors of c that add up to b. We have 32 times 1 is 32, but when we add them, we get 33, so that doesn't work. 16 times 2 is 32, but when we add them, we get 18, and that doesn't work. 8 times 4 is 32, and when we add them, we get 12. So those are our two numbers that we're going to use and place in our empty spaces here. And it doesn't matter where they go. I'm going to put 8x there and 4x here, but we can switch them if we wanted to. And now we need to figure out what our factors are outside of the box. Okay? And the way to do this is I'm going to start here. So I'm going to look at what the GCF is of this row. So what's the greatest common factor of x squared and 8x? They don't share a number. They only share an x. So we're going to pull out an x. Now, we could keep going and look at the GCF for all of these. So the GCF of this column and put it there. Or we can think back to what we learned prior to when we were multiplying using the box method. So you can say x times what is x squared? And that's x. And if I look, the greatest common factor between x squared and 4x is just an x. Okay. Then you could say x times what in this blank right here will give me 8x. And that's 8. X times what will give me 4x, and that's 4. And let's double check the last one. 4 times 8 gives us this 32. So if I scroll down, the book has the same answers, x8, x and 4. And then we need to just write these as two binomials with parentheses around them. Scrolling is being funky today. So at the bottom, you're going to see that the answer is x plus 4 and x plus 8. And the order here does not matter. You could switch these and you could write x plus 8 first and x plus 4 second. So that means the same thing. So let's go to our note sheet and let's do a few examples of this. So if we're looking at this first example here, we have x squared plus 9x plus 20. So x squared goes in the upper left, 20 goes in the bottom right. And we're looking for numbers that multiply to get 20 and add or have a sum of 9. So if I do 1 and 20, 2 and 10, 4 and 5. Okay, use your factors chart or a multiplication chart to help you if you need it. When we add these, we get 21. It doesn't work. 12, that doesn't work. 9. So these two are our factors here. So I'm going to write 4x here and 5x here. And remember, if you switch these, it doesn't matter. You're still going to get the same answer. So let's try to fill in. So I'm going to start by looking here. What's the GCF? They share an x. X times what is x squared? X times what is 5x? X times what is 4x? And that would be 4. And then 5 times 4 is 20. So x plus 4 is the first set of parentheses. X plus 5 is the second set of parentheses. And again, order doesn't matter. If you want to write the x plus 5 first, you're still going to get the same answer as me. Now, how would we check our work here? Well, we could do the box method for multiplying, or we could think about the distributive property or foiling. So first, outside, so we're going to multiply this back through. Inside, last. Then we have like terms here that we need to combine. So when we do that, we get x squared plus 9x plus 20. And is that the original question that we started with? I scroll back up. We did start with x squared plus 9x plus 20, so we know that we solved this or factored this correctly. All right, let's try m squared minus 8m plus 12. So m squared goes in the upper left, positive 12 goes in the bottom right. And we're looking for numbers that multiply to get 12 and add to get a negative 8. So 1 and 12, 2 and 6. Ooh, 2 and 6 is probably going to work. If I add 1 and 12, I get 13. If I add 2 and 6, I get a positive 8. So what do I need to do? If I change this to a negative 2 plus 6, I get 4. That doesn't work. If I have a positive 2 and a negative 6, I get negative 4. Plus, when I multiply those, I get a negative 12, so that doesn't work. So think, positive times positive equals a positive, or negative times negative equals a positive. So if I make this a negative 6 as well, negative 2 times negative 6 gives me that positive 12. And then when we add those together, we do get that negative 8. So these two are going to be our answers here. I'm going to write negative 2m here, negative 6m here. It's really important that you plug in those m's with it. Don't forget the m's. All right, we can start here. It doesn't matter where we start, and our answer will go up top. So if I'm looking at m squared and a negative 2m, they don't have a number in common. They only have an m in common. That's the greatest common factor, the GCF. If I look here, what's the GCF? Or m times what is m squared? And that would be m. So m squared and negative 6m, the common factor is just 1m. All right, for this space right here, m times what is negative 2? And that's negative 2. m times what is negative 6, and that's negative 6. And let's look the last two, negative 2 times negative 6, we do get a 12. So make sure you write your answers in parentheses as two binomials being multiplied together. And again, order doesn't matter. You could write m minus 6 first if you wanted to. So if we're looking here, back in the book, sorry, let's go to the Try These A, question A. And almost all of this is done for us. So they put in the x squared, they put in the 8, and they're telling us that one of the factors is negative 4. So what would the other factor be that multiplies to get a positive 8 and adds to get negative 6? That would be a negative 2. So let's look at the greatest common factor between x squared and negative 2x. Right here. They share an x. X times what is x squared? X times what is negative 4x? X times what is negative 2x? And then when I multiply negative 4 times negative 2, we get that positive 8. So it would be x minus 2, x minus 4. All right, try question B. I'm going to have to draw in our own box here. Numbers that multiply to get 45, add to get 14. The two numbers that came to mind right away were 9 and 5, and those work. And again, it doesn't matter where you put the 5x and the 9x, but make sure you include the x's here. All right, looking here, what's the GCF? The greatest common factor between x squared and 9x is x. Here, the greatest common factor is also x, and x times x is x squared. So x times what gives me 9x? That would be 9. X times what gives me 5x, and that would be 5. 5 times 9 is 45. So we know we have the right answer there. And let's write it as two binomials. And again, order does not matter. All right, we're going to skip C and D for right now. And I am going to ask you what you notice. What were our two factors that multiply to get 32 and add to get 12? They were 8 and 4. And what was our answer here? Our answer was x plus 4 and x plus 8. On our note sheet, the two numbers that multiply to get 20 and add to get 9 were 5 and 4. And look at my answers, x plus 4 and x plus 5. The two numbers that multiply to get 12 and add to get negative 8, that's negative 2 and negative 6. And my answers were m minus 2 and m minus 6. So do we always have to keep using the box set method here? No, we do not. Okay, so there is going to be a faster way to do this, and let me walk you through some examples. This is called the guess and check method, and this is what I learned when I was in high school, and this is the only way I learned. So we're looking for numbers that multiply to get 21. Always start there. And then they add to get 10. So 1 and 21 don't work. 3 and 7 work, because when I add them, I get 10. So our answers here would be x plus 3, x plus 7. So look how much faster that was than using the box method. Okay, let me do one more, and then we'll add it to our note sheet. Numbers that multiply to get 15 and add to get a -8. So because my middle term, that b term, is negative, I know that both of these have to be negative, but that makes a -16, so that doesn't work. 5 and 3 works. And again, I know that they have to be negative because negative times negative is a positive. And when we add them, we get a -8. Okay, so those are my two factors that I write inside my parentheses. In order does not matter. Again, you can always go back through and check your work by foiling first, outside, inside, last. Combine my like terms. And we ended up with what we started with. So we know that x minus 5 and x minus 3 are the correct answers. So on our note sheet, it says factor using the guess and check method. It's also called the T-chart method because you draw a T-chart to find numbers that multiply to get 18 and add to get 11. Three and 6 don't work. 2 and 9 work. So x plus 2, x plus 9. And how do we check our work? First, outside, inside, last. Or you could also use the box method to check your work if you would like. Oops, and of course I used x's instead of n's. My bad. But hopefully you get the idea that it's the same. These technically should be n's. I totally neglected to look at the variable. So now you're going to have a worksheet. You can choose whether you want to use the box method, algebra tiles, or guess and check.